So, what is a star?
So stars are basically hot bodies of gas that start their life in nebula. They vary in different masses, temperature and sizes. The diameter is usually from 450 times smaller to 1,000 times larger than that of the Sun. Masses range from 20 to 50 solar masses. The surface temperature range from 3,000 Celsius to over 50,000 Celsius.
Birth of a star.
Stars are born in a region of high-density nebula, a huge cloud of gas and dust. This nebula is about 21 light-years, or 125 trillion miles across. Part of the nebula begins to shrink under the pull of its own gravity, and condenses into a huge globule of gas and dust and contracts.
A region of condensing matter will begin to heat up and start to glow, forming protostars. If a protostar contains enough matter, the central temperature reaches 15 million degrees centigrade.
At this temperature, nuclear reactions in which hydrogen fuses to form helium can start. The stage begins to release energy, stopping it from contracting even more and cause it to shine. It is now a main sequence star.
Stars live out the majority of their lives in a phrase termed as the main sequence, approximately 90% of their lives, and the nearest main sequence star to Earth is the Sun.
Death of a star.
A star of one solar mass remains in the main sequence for about 10 billion years, until all the hydrogen has fuses to form helium. The helium core now starts to contract further, and reactions begin to occur in a shell around the core. The outer layers begin to expand, cool, and shine less brightly. The expanding star is now called a red giant. These red giants have a diameter of roughly 60 million miles.
The red giant begins to brighten between 1,000 and 10,000 times. The helium core runs out, and the outer layers drift off away from the core as a gaseous shell. This gas that surrounds the core is called planetary nebula. The remaining core, that's 80% of the original star, is now in its final stages. Over a few 100 million years, the core shrinks into a white dwarf, about the Earth's size, and eventually cools and dims. When it stops shining, the now dead star is called a black dwarf.
If a star starts off with a mass of less than 8 solar masses, then it will stop at the red giant stage. More massive stars will continue to burn. The massive star then becomes a red supergiant and start off with a helium core surrounded by a shell of cooling, expanding gas. The massive star is much bigger in its expanding stage.
In the next million years, a series of nuclear reactions occur, forming different elements in the shell around the iron core. The core collapses in less than a second, causing an explosion called a supernova, in which a shock wave blows the outer layers of the star. The actual supernova shines brighter than the entire galaxy for a short time.
Sometimes the core survives the explosion. If the surviving core is between 1.5 to 3 solar masses, it contracts to become a very tiny, very dense neutron star. A typical neutron star has a mass between 1.35 and about 2.1 solar masses, but its size just about the size of a large city, which is about 20 to 40 kilometers in diameter.
If the core is much greater than 3 solar masses, the core contracts and becomes a black hole. Because there is so much mass and no nuclear reaction inside of the star to compensate for it, the gravity continues to crush the star. Eventually, the gravity gets so strong that it even holds back light.